So we have a 12-foot board suspended from 2 points right here in the classroom. On the left side of the board, one foot from the left side, we have a spring scale that measures the force that supports the board there. So we're going to put this on the free body diagram. This all starts with the free body diagram. So 1 foot in from the left side of the board. I'm going to call this a tension. So that's equal to 72 newtons, because that's what the spring scale tells us. Moving over to the right, smack in the middle of the board is where we draw in the weight of the board. Because for a uniform object, such as that board right there, where do we find the center of mass? Directly in the middle. And that's where you put the weight of the object. So we'll label this W for weight of the board. And then 3 feet in from the right end, we have a second force acting on the board, an upward force suspending the board. We'll call this one T2. So let's call this one T1. So we have tension 1 and tension 2. We do not know what tension 2 is. All right. How many forces act on this board? 3. How many of the 3 do we know? Only 1. So we're missing 2 forces. We don't know this, and we don't know this. Now you guys are all smart. If you have 2 unknowns, as we do here, then you must have 2 equations. Now, you now know enough physics to write 2 equations for this situation. Now the first equation, so let me shrink this all down and make some room here. So I'm going to erase, let's get rid of that. Shrink this down. Okay, so the first equation, who can tell me? What could we do with what we have right there? Right, or we could sum the forces. Okay, so summing the forces, the sign convention you use, you're just going to say up is plus, down is minus. So you would go 72 newtons up plus T2, which we don't know, minus W equals ma. Sum of the forces always equals ma. What's the acceleration of that hanging board? 0. So we could just set this equal to 0. Now, we just wrote one equation. How could we get a second equation out of this? We could apply torque. Now look, is that board going to rotate? No, not unless one of the supports broke, then it would rotate. So for a situation where there's no rotation, and in fact there's not even an obvious axis, there's not even an obvious point that the board would rotate from. Like when we did the seesaw, when we looked at the seesaw, there is an obvious axis. So look, the question becomes, where do we put the axis of rotation? Because whenever you deal with torque, look at the torque equation. Torque equals force times lever arm, right? How do you get the lever arm? The lever arm is measured from where? From the axis. You measure the lever arm from the axis. So the thing that I'm explaining here is, where do you put the axis when there is no obvious axis? Well, the answer is you can put it wherever you want. So let me just show you this. Let's just say we put the axis right here, and you'd have to define that point, right? You'd have to say, like, that point is 4 feet in, or 3. Let's just say it's 3 feet in. That's 3 feet from the left side. This force, we're told, is 1 foot from the left. This force right here would be right in the middle. This force here is 9 feet, because we're told it's 3 feet from the right, and it's a 12-foot board. So that's 12 foot right there. So if we say that this is the axis, right? If we say that this is the axis, the distances that we're going to need this distance, and this distance, right? And notice that those are all perpendicular from the axis. perpendicular to the forces? Okay, so what would the summing of torques look like? Okay, what's the sign convention for torque? Is the sign convention for torque going to be this? Are we just going to say up plus, down minus for torque? No, because what's torque all about? It's all about rotation. So in fact, let's get rid of this. That was for forces. The sign convention for torque is clockwise, counterclockwise. So pay attention here. This is where kids sometimes have trouble. It's really not too hard. Whether or not a force is considered clockwise or counterclockwise all depends where the axis is. So if this is our axis right here, which way is T1 pulling on the board? Would that be clockwise or counterclockwise? That would be clockwise. What's this guy doing to the board? And you gotta pay attention to where the axis is. The weight of the board would be pulling how? Counterclockwise. And then what's this guy doing? Counterclockwise. Okay? So let's say that counterclockwise is plus and clockwise is negative. Okay? All right, so the summing of the torques would look like this. Let's start with T2 right here. So you would go T2. Now what's the distance for T2? Well, let's see. From 3 feet, so from the axis over to T2, how far is that? From 3 feet to 9 feet is what? 6 feet. And is that perpendicular? Yep. Okay. Plus, let's go to the weight. Plus W. Now what's the lever arm for W? What's the distance from the axis from here over to W? Let's see. From 3 feet to 6 feet is how far? 3 feet. And then minus for our clockwise torque, minus 72. And then what's the distance for 72? From the axis, from 3 feet to 1 foot is what? 2 feet. Okay? And then the sum of the torques will equal 0 because we don't want any rotation. If you do end up with a net torque, then you get what's called an angular acceleration. Now, guys, we now have what? 2 equations and 2 unknowns. So the 2 unknowns are T2 and W. And I'm just going to tell you what they come out to be. So W comes out as 192, and T2 comes out as what? 120. Okay? You can solve the algebra. Now look, having done this, I want to show you a much easier way. Who likes easy? I like easy. In fact, you know what? Anybody have an easy button? I got to get an easy button. I like easy. Okay. There's an easier way. So let's back way up. So any questions on this before I show you the easy way? Any questions? Okay, so I'm going to clean this up quite a bit. In fact, you know what? I'm just going to redraw the whole thing. Sorry. That's too messy. So here's what we had. I'm going to redraw real fast. So we had T1 over here. So bear with me one sec. T1 was 72 newtons. The weight of the board was in the middle, like this. And that's a question mark. And then over here we had T2, which is also a question mark. Okay? And then over here, this is the 0 end of the board. That's 0 feet. This is 1 foot right here. This right here is 6 feet. This right here is 9 feet. And then this is 12. It's a 12-foot board. All right. Who knows how to make this a much quicker problem? Much, much quicker. What can you do?
Can't you put the axis on the point where the tension changes?
That's it. So look, let's say you want to find the weight of the board. You want to solve for the weight of the board. The quickest way to do it, I'm almost done. The quickest way to do it, put the axis at one of the unknown forces, or I should say the other unknown force. If you make this the axis, T2 will not appear in your summing of the torques. Because remember, a force that is on the axis causes no torque. A force on the axis causes zero torque. So if that's the axis right here, so then we're going to use this distance there, that distance there, and they're perpendicular. Okay, look, is this guy clockwise or counterclockwise? And you gotta pay attention to where the axis is. If the axis is right here, what's T1 doing? Clockwise or counterclockwise? Clockwise. And then what's W doing? Counterclockwise, like that. So let's say that counterclockwise is plus, clockwise is minus. So now let's sum the torques. It's a much faster calculation. We can solve for W. Okay, so we're going to go the weight of the board. What's the distance for weight now? From 9 foot to 6 foot is how far? 3 foot. And are they perpendicular? Yep. Minus 72 newtons. Now what's the distance for 72? From the axis over to the force, let's see, from 9 feet to 1 feet is 8 feet. Some of the torques will be 0 because it's not having an angular acceleration. Take this, solve for the weight of the board, you get 192. Now, once you have the weight of the board, you can easily find what T2 must be by looking at the forces. What has to be true about the total up force and the total down force? They have to be equal. So we got 72 up plus a question mark, and then we now know that this W right here is 192. So what does T2 have to be? It's got to be 120. That's from the summing of the forces. Should I show that with summing of forces? Did I make a mistake?
No.
So look, all I did here, because some of you were like, what? It's summing forces. You go 72 up plus T2 up minus 192 down, and all of this must equal 0. So T2 has to be 120.